Alright, for this lab, the maximum angle lab, you are going to try to figure out what angle you are going to have to shoot your cannons at to make the cannonball shoot the furthest. So first, I want to kind of walk you through the cannon and how it works so you have as much information as possible. So number one is to change the angle. You can unscrew the two screws on the back of the cannon just a little bit, and then you can tilt the angle of the cannon, and then you can tighten them back down at whatever angle you feel is most appropriate. You will need to use at least 10 angles in this lab to narrow down what angle it is, and when you're doing it, please try to get a large range of angles. So don't do 40, 41, 42, 43. Do 10, 20, 30, 40, 50, 60. The larger the range, the better your graph is going to look at the end. So you can change the angle, and to measure the angle, you're going to need a flat object. I recommend using the rulers on the bottom right shelf on my wall and lining it up, and you can see, hopefully, this little dot right here at the top. That's the center of the protractor. These cannons all have a protractor built in so that you can find the angle. So if you take any straight object, and you can even use the highlighters, and you keep it flat on the ground and line it up so it's lined up with that dot on the top, and then come straight down and measure the angle. And I can't see that angle from here, but when you're up close, you'll be able to see it. It looks to be about, I don't know, 28 degrees. Whatever your angle is, that gives you your first angle. When you're not trying to look at it in the reflection of an iPad, you'll be able to tell quite easily. You can place the cannonball in, and then you can change the power level. It has 3 power settings. Power 1 with 1 click. That won't shoot it as far. Power 2 with 2 clicks. And power 3 with 3 clicks. By the way, the only thing that should go into these cannons is a marble and a ramrod. And I've left both of those things on the counter for you. And then to launch it, hold it firmly by the base so that you don't change the angle, and then pull the trigger to launch the cannon. Alright, so as I discussed before, there's 2 things to be careful of when you're shooting your marble. Number 1, it should land at the same height that it comes out of the cannon. So it should land at the same height. That's why I have this cardboard box there. Also, you're going to maybe struggle to know exactly where it lands. So once you've taken a couple of practice shots, to make it a little bit more precise, if you place a piece of paper flat down and use this black carbon paper, you notice how it has a black side and kind of a paler side. If you put it black side face down, and I had to fold this to bring it home, but your pieces should lie flat, and then when the marble lands, it should make a perfect dot so you know exactly how many inches over it landed. I hope that helps, and I hope that makes this a little bit easier. Alright, so now let's walk through the rubric that you need to use as you're going through this laboratory. This rubric is found in the kinematics, the motion folder in Schoology, so you have access to this, and you should use it as a checklist as you go. Again, I want to remind you of your overall goal for this lab. You're trying to figure out which angle will shoot the cannonball the farthest. And I think to better understand that, you should first see what the picture looks like. So if we have a cannon, and this is the ground, and this is your cannonball, as it launches, it's going to land some distance away, where this horizontal distance from where the cannonball comes out of the cannon to where it lands, that's going to be your range, or the horizontal distance that it will travel. The angle that it comes out of the cannon, is going to affect that. So if you make it steeper, will it make it shoot further or longer? As you make it flatter, will it make it shoot further or longer? That's your goal. And as I said in the video before, you need at least 10 different angles. You might need more angles. So let's say after your 10 angles, you find that it's between 50 and 55 degrees. You would need to narrow in and say, okay, now we're going to try for it 53, we're going to try 54, and then you find 54 is the angle that shoots it the furthest. I don't know that that's the answer you're going to get. I'm just trying to give you a hypothetical situation. As you're doing this, this is your first full, proper laboratory report, which means I'm going to be looking at it very closely to make sure that you have all of these details in there and you have them in there properly. And this rubric is designed directly from a college laboratory rubric. So the goal of this is, or at least the major goal of this, is to make sure you guys get better at making proper laboratory rubrics. So please use this as a checklist after you're done and as you're going. See how I have each one of these sections outlined? As you're working through this, you should also outline your sections neatly and clearly as you're going. So when you get to the title section, the first section, it should be a very clear, this is your title section. When you say get to the purpose section, you might even want to write purpose and underline it. So that way I know I've gotten to the purpose section. I should not have to hunt to find any part of this. It should all be clearly organized. That's why I have it clearly organized here for you. So let's walk through each one of these. First, the title section. You need a title. Make it fun. Shooting cannonballs at faults. You need a date. This can either be the date that you start the lab, the date you finish, or a range of the date you start to the date you finish. Any of those will work. You need your name and your partner's names in there. And you only have to do one of these for all of your group members combined. So my recommendation is you use Google Docs and do collaborative mode so you guys can be working together as you go. And when you're in class, your goal will be to try to collect the data, because you can fill in these other details later and you will get at least 3 class days to work on this. So you do have plenty of time, but that time goes by quickly, so please waste no time as you're going. So if you go into Google Docs, you can go into collaborative mode. One person can be drawing the apparatus while another person is writing out the procedure, while another person is writing in the title section. So that way you guys can be working together, but the other half of that is double check each other. I've never once in my life turned in a laboratory report where I didn't look through everything that all of my group members also did. And they did the same for me. It's checks and balances. You gotta check each other and make sure you guys are doing what you need to do. So now that we've gone through that, purpose section. This is just your hypothesis. Now, because you are a group working together, you're probably going to have different hypotheses. And for that to work, just write different hypotheses. So Joseph, for example, his hypothesis was vuzha, and Dr. Dog's hypothesis was vuzha. So you're probably all going to have different hypotheses. Now, what should your hypothesis look like? That should be kind of an if-then statement. If I shoot the cannon at a flatter angle, then I think it will go further. If I shoot the cannon at a steeper angle, then I will think it will go further. And by the way, when you're working through this, this is 0 degrees, and it goes all the way up to 90 degrees. It should be somewhere between 0 and 90, and all of the angles that you shoot it at should be between 0 and 90. In the other video, or the first half of this video, walked you through how to measure the angle using the protractor on the cannon. As far as measuring the range of how far it goes, there are tape measures on my third shelf from the left in a little bucket in the back corner of it. Third shelf from the left in the windowsill. And your units cannot be mixed, but we'll get back to that when we get to the data section. Now, apparatus. This consists of two parts. You need a label diagram and a separate list of all materials used in the lab. So your label diagram, we're already halfway there. So this is going to be my apparatus section. So I would just have to fill in any other things that I need to be labeled. Marble, angle, cannon. That's pretty much it. But don't forget, you also have to have a materials list. And materials list doesn't have to be filled out before you get to work. You can add to it as you go. So I already knew that I needed a cannon. I already knew that I needed a marble. Maybe you find out you need a tape measure. Add it into your list. Maybe you figure out you want to use carbon paper. Add it into your list. So all of those things, add them as you go. Anytime you pull out a new material, slap it in your material list. Procedure. This is relatively straightforward. Walk me through how to do your lab. And the purpose of both the apparatus section and the procedure section is because when scientists do any scientific study, the goal is to share that information with other scientists. And so that other scientists can scrutinize them and check their work, you need to clearly explain how you set it up so they can see whether they trust how you set it up, or so that they can retest it and confirm your results as well. So the procedure section doesn't need to be complete sentences. Step 1, set up the cannon at Vosges angle, and be consistent about how many clicks of power you use. I said in the video you could use 1, 2, or 3 clicks. It doesn't matter which of those 3 you use, as long as you're consistent and you use that same power setting for the entire lab. Otherwise, you're going to get skewed data where let's say you shoot it at 30 degrees with 1 click, that's going to not line up with if you shoot it at 50 degrees with 2 clicks of power. So please be consistent. The only thing you should be changing is the angle. That's your independent variable. That's your cause. That's the only thing that should affect your dependent variable, the range. So procedure is good. Data, we've gone through how to set up a proper data table in, I believe we used Numbers, but you can also use Google Sheets. But you guys saw how that was set up. Independent variable always comes first, dependent variable always comes second. So the thing we're changing is the angle, and that's measured in degrees. And the dependent variable is the range, and I don't know what you're gonna measure that in. That's up to you. You can measure it in inches, centimeters, feet, but it can't be mixed units. And what I mean by that is it won't be able to spit out a graph if you shoot it and it goes, let's say 2 feet, 2 inches. If you put 2 feet, 2 inches in here, it's not going to be able to read it. In fact, if you have feet or inches typed in there, it's not going to be able to read it. You can't put units in the actual cells. That's why it goes in parentheses at the top. So instead of 2 feet, 2 inches, I'm going to convert this to pure inches. Well, 2 feet is 24 inches. And we're going to add the extra 2 inches, so that's going to be 26 inches total. So when I shot it at 10 degrees, it went 26 inches. And just another reminder, that gray shaded cell in Numbers, you can't have any actual numbers or data written in there. That's for your titles like angle and range. So procedure is the step-by-step walkthrough. Your data must have rows and columns neatly organized and must have at least 10 different data points. Analysis. This is where I want you guys to put your graph. There aren't any calculations for this, but you will get a graph And again, I showed you how to do that. If you can't remember how to get a graph, I encourage you to look back from when we did the tennis ball laboratory report and watch my video on how to highlight and select your data. And as you highlight and select your data, it should give you in numbers the option to insert a graph. So if you go back to the tennis ball laboratory, if you don't remember how to do that, I have that video in there walking you through how to convert a data table into a graph. So your analysis section is number 1, make the graph. Number 2, identify which angle made it shoot the furthest. And that should hopefully be abundantly clear. Because when you get your graph, I don't know, you're going to have a bunch of different points, and whichever one of those points shoots at the furthest will hopefully be the will tell you the angle that shot at the furthest. So any observations you need to do, and just like with all other graphs, don't forget you need a trend line, you need unit titles, you need an actual title, which is always in the form of y versus x, so this would be range versus angle. So you're going to need your graph and a sentence explaining which angle shot at the farthest based on your graph. So a graph and a sentence, and that takes care of the analysis section. Conclusion section. This consists of 3 parts. Number 1, you need to restate your hypothesis. And you can just go with one person's hypothesis or state that you each had different hypotheses. One person thought it would be 10, one person thought it would be 80, one person thought it would be flatter, one person thought it would be taller. So restate the hypothesis and discuss how you obtain the data, and then discuss whether that data supported or disproved your hypothesis, and then potential sources of error. Now, potential sources of error should never, ever, 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 ever include human error. That is not a source of error. If it's something that you can fix, fix it. You can't say, oh, we think the angle slipped or we mismeasured the angle. No, 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 never. If you mismeasured, go back and remeasure and retest. Human error is not a real source of error. That's garbage. All right. So actual sources of error will be things that you can't affect. So when a cannonball is flying through this stuff, that's going to provide resistance that's going to change the physics findings. And I think you guys will find that the cannons are not consistent. That's going to affect your findings. What about the cannons is inconsistent? So you're looking for laboratory equipment errors or humidity errors or air resistance, all of that stuff. Those are your sources of error. Also, while I'm on the subject, when you're shooting your cannons, they all shoot with different power levels because their springs have weakened or changed over time. So if you're using one cannon on one day, you need to use that same cannon consistently through the entire lab. The cannon I was using was labeled Dora. I'm going to make sure I get Dora out every day I do this lab. So please be cautious about that. So now that I've discussed all 4 of these, an example of your conclusion would be, I thought that shooting it at a flatter angle would shoot it the furthest. To test this, I set up a cannon and shot it at various angles across a large range and measured how far it went. I feel that the data did not support my hypothesis because I found when I shot it at a steeper angle, it shot further. However, this might be affected by the sources of error of Vouget and Fouget. Now, creativity. I don't know, do something fun with it. Insert a picture of Foltz being shot with a cannon. Make it your own. I have a lot of these to grade. Give me something to get me through it. Make it fun for me. And that's it for the entire rubric. I have two last things that I want to point out to you, two kind of challenges to put to you. Number one, the marble will bounce or roll. That segment should not be included when you're measuring the range. It should be where it lands on the dot. After I finish this video, I will insert one more video at the end that includes how to use the carbon paper to measure exactly where it lands. That's trick number one. Trick number two is it cannot be cliff to ground. What I mean by that is when you're shooting your cannon, it has to land at the same height that you shoot it. Otherwise, you're going to get results that don't give it proper physics results. You want it to land at the same height that you shoot it. So it can't land lower than you shoot it. It can't land higher than you shoot it. You might want to imagine a straight plane coming out at the head of the cannon. Now, because the cannon has some height to it, right? It's coming out here. It's not coming out at the base. That means it's not going to land at ground level. So even if I get rid of my ground, if you're shooting it in the classroom, it's not going to land at the same height you launched it at. You may need to stack up some books or some cardboard boxes. That's why I left cardboard boxes on the counter for you, for wherever it lands. My recommendation is you shoot it once or twice and have your lab partners on the other side eyeballing where it's landing, and then place a stack of books or a box there to measure exactly where it lands. And that should be relatively straightforward. And the other thing that I saw some groups doing to make it easier is the range is just from where the cannon head starts to where it lands. To make that easier, a lot of times if you have a bunch of whiteboards stacked up, they're heavy as the dickens, and it's a pain moving them. Instead, move your cannon over. That didn't move as easily as I wanted it to, but you get the idea. Move the cannon. Your distance from where it shoots to where it lands will still be the same, and the cannon's much easier to move than it is to move your stack of books or your landing pad. So the people over here might say, you need to move the cannon forward about 18 inches. You get the idea. So I'm going to go finish up that, show you how to use the carbon paper, and aside from that, I hope all of this made sense. If you have questions, please don't hesitate to reach out to me, and I hope it goes well. Thanks. Bye.